very important due to their fundamental nature. Am I clear, all of you? Zainab, Mariam, and Aisha. Oh, sorry,
Yes.
Abdul. Sure. Great. Okay. Now let me write the thing. So now let's just, so basically what is electric current in the basic language? Can anybody tell me?
The flow of charges.
Okay, the flow of charges. Mariam, what do you say?
Sir, I had the same answer.
Okay, ठीक है. Abdul, what do you mean by electric current? So I'm asking something. Please unmute yourself and let me know the answer. Abdul, please speak.
Can you repeat?
I'm asking, what do you mean by electric current? Any idea? Sure. Okay. So basically, in the simple words, electric current is the flow of charge in a given conductor. Because conductor is required for the flow of electrons or for the flow of charges. If I'm talking charges, that means I'm talking about the electrons by default. Because we are talking about the electricity, so electron will be there. Am I clear to all of you?
Yes.
Sure, that's it. Okay. So I'm writing this thing. So now I'm going to define the electric current in the you can say as as per the formula, right? So that's the formula that we are going to discuss. Okay. Magnitude magnitude of electric current. Just a second. My hands are a little bit slippery right now. Electric current in a conductor. Okay. Charge is the amount of charge passing through a given point of the conductor in one. Okay. So it means that whatever the number of like charges are flowing through that conductor in 1 second in unit time, that is called the electric current in terms of charge and time. Am I clear to all of you?
Yes.
Yes, sir.
That's great. That is I is equal to Q by T. Okay. So this is the definition of the electric current in terms of the charge and time. So another definition, that is a general definition that we use to say in normal words, that is the flow of electrons in a conductor is basically your electric current. Am I clear? Zainab, Mariam, and Abdul.
Sir,
The electric current is the flow of electric charge in a conductor. Okay?
sir,
Yes, Zainab.
what does I represent?
I represents the current. Just like V represents the voltage, I represents the current, Q represents the charge, T represents the time. Clear, Diana?
Yes.
So in normal word, the electric charge, the electric current is the flow of electric charge in a conductor, such as a metal wire. Okay? Am I clear to all of you? Please do let me know.
Yes.
Okay. And SI unit of current would be ampere. Okay, SI unit of current would be ampere. Electric current basically. Because in general words, the current represents the flow. Okay, if you use electric current, it means that it is the flow of electric charge. Because in the normal word, we also say that there is a current of water, right? It means that water is flowing. You must have heard this phrase very frequently at the beaches, okay, at the seashore. So that phrase is used for the flow of water, water current. Doesn't mean that electric current is flowing through the water. That says this is the flow of water, water current. Okay, the electric current. Have you heard this word, water current?
I think I've heard it like when we were studying about like how water can produce like generate electricity
Electricity,
at
yes,
that time.
yes. That is current means flow. That's why they wrote the word current, right? The unit of electric current is ampere. Okay, that is your A. Clear all of you?
Yes.
C point. C
So
point is
instead
this.
of I, we could also write A.
No, no, no. I this is I'm writing Q is equals to 2 coulomb. Q is representing the charge, coulomb is the SI. It means that I have to write, if I need to show it as a current, so I is equals to 2 ampere. I is the current, ampere is the SI. Clear, Zainab, Mariam and Abdul?
Okay.
Okay. So I represents the current value. A is the ampere, the SI unit. It shows the ampere, right? Now I'm going to basically define 1 ampere of current in terms of 1 coulomb of charge in 1 second. So everyone see this thing. If I substitute the value of 1 coulomb and divide it by 1 second, both are SI units. So 1 ampere of current is flowing through that conductor. Yeah, right. So this could be a question in your exam that define 1 ampere. So that would be a question for you that define 1 ampere. Now you have to basically define it right there. Okay. So you have to write it like this. When this is a very important question, everyone. Just like we have proved just like we have defined 1 volt. Okay. 1 ampere of 1 ampere, sorry, not 1 coulomb of charge, sorry. 1 coulomb of electric charge flows through an cross section of a conductor in 1 second. The electric current flowing through it is 1 ampere. In one ampere. Please do let me know everyone if it's clear to you or not. Zainab, Mariam, and Abdul.
Yes, sir.
Jabbar. Okay,
So, what
please
does
stand.
cross-section mean?
Cross section means the area. Just like basically, uh, conductors are generally the cylindrical type thing, right? The wires are cylindrical and circular. So cross section means that thing, this area, cross section. Clear?
Oh, okay.
Yeah. Now, now let's discuss the next thing about the electric current is. So basically, just like we have voltmeter to measure the potential difference or voltage, similarly, ammeter is there to measure the current in the circuit. Am I clear? So electric current is measured called ammeter. Yeah. The ammeter is the device that is used to measure the current. Is that clear to all of you?
Yes.
E part. So basically, E part, that electric current is measured by ammeter, and ammeter is connected in series combination with the circuit, okay, with the battery. Just like we have done in the voltmeter, voltmeter is connected in parallel. So similarly, ammeter is connected in series combination, so that the more current can pass through it, so that to get the accurate reading. Because ammeter is the device, so it will give you reading. So more the value of current will be there, accuracy will be increased. Clear? So that's why it is connected in series. I will explain all the things in the what is series, what is parallel in the combination of resistors, because this is a specific topic. If I right now explain it right, if I explain it right now, so you won't be able to understand it properly, because that is a little bit out of way topic. Okay, so we'll do it when we'll do the combination. Am I clear to all of you? In series, next thing, F point. So F point basically says that everyone, that the ammeter should have very low resistance, because if the resistance would be high, so current will not pass through it properly due to the high resistance, and it will, okay, so due to that ammeter will not provide you the accurate reading. So that's why it is recommended to, keep the resistance as low as possible in the ammeter, right, so that we can get the accurate reading. Am I clear to all of you? Okay, so ammeter Very low. Please do let me know everyone if it's clear to you or not. Is there anyone who is having a doubt? Yes, tell me, sir. Do you have any doubts so far?
No, sir.
Sure, sure.
Yes.
Okay. So, one more thing. Let me tell you that 1 milliampere is a smaller unit of ampere. So it basically equals to milliampere is written as 10 to the power minus 3 ampere. Clear? It means that milliampere means you have to divide the ampere by 1000, right? If you are converting the smaller unit into bigger unit. Am I clear? That's it. Please write it down and let me know. Let me explain some topic. Okay, that is the direction of, this is very important, everyone. Direction of electric charges. Right. Okay. Electric charges and current. Now let me write it over here. That is the first point.
So what's
And
the
then
first letter S? What's the first
direct
word?
direction. DRI. This is the short form of the direction. So you can use them in note, but not in the exam. Okay. Keep this thing. Okay. Let me paste some pictures. Let's just a moment. Let me show. Okay. Now let's discuss this portion. Right. So this portion is, as you can see this thing, everyone, that first image is showing that a wire is there, and in this wire, electrons are in random direction. Right. They are colliding with each other. They are colliding with the walls of the metal wire. Right. So there, there's no specific direction. They are going backward, to and fro motion like that, just like a pendulum. They're going forward, backward, sideways, downward, everywhere in the metal. Right. So this is the actual movement of the electrons in a material, right? But as you can see, the next picture that is given to you right now. So as you can see, when once you have connected the battery or a cell, once you have maintained a potential difference between the 2 points of a wire, electrons are aligned like the attention manner. Yes or no? Right? They are aligned in the attention manner, just like we do in the parade or the assembly in the school, right? Attention word, right? So as you can see, the electrons are aligned in the attentive, like in the specific manner. This is due to the this is due to the potential difference maintained. And you can see this thing, electrons direction is coming from negative to positive, because if you see this thing, negative will repel negative. Basic property of charges that we have discussed in the first class of the electric charge. Do you remember, Bacho? Mariam
Yes.
and Zana? Right? So that's why electron will, this negative will say that please move on the leftward towards the positive charge, because I cannot bear you at all, because you are of the same category of mine, right? Positive, negative, and negative. So due to that, due to the fundamental property of charge, the electrons will flow from negative to positive due to the repulsive nature of the negative charge. Am I clear?
Yes.
Any doubt so far, Mariam and Zainab?
So
No,
it
sir.
is something called conventional current below it.
Yes, yes, yes. I'll tell you conventional current. I'm just telling you right now the direction of electrons.
Okay.
Clear, Mariam and Aisha? Mariam and Zainab, sorry. That's great. Now, this is basically the internal part. Right now, it is not visible in the, like it's in the metal. Can you see the electrons with the naked eye? No, no, that's not possible. So that's why this is called internal circuit thing, right? Now, because we cannot see the internal thing, right? But we know this thing that the electrons will move from negative to positive because electrons repel the same charge, like basically the negative same sign, negative to negative. The basic property of the charge, whether it's positive or negative, they will repel with the same charge. Clear? Now, I've told you in this in the potential difference class, Bacho, that potential difference is like a tank. One tank is filled with water, another tank is just like half, like almost empty, right? If you connected a wire, if you connected a pipe, if you connect a pipe between those tanks, you can see this thing. Water will flow from higher to lower point. Yes or no? Right?
Yes.
Similarly, so this is the in the electric current chapter, electricity chapter, we take positive as the higher potential, negative is the lower potential because cell is already a basically cell has already maintained a potential difference because if there is a cell, it means that the value, if I'm saying that 6 volt of battery, it means that potential difference between the positive and negative sign is 6 volts. It clear, everyone? Right? So that's why the current will flow from the positive to negative. It means that higher to lower. I've told you in the potential class that the current electric charge flow through the positive to negative. Clear?
Yes.
So that's why the conventional direction of current is from positive to negative. That's clear to you. Basically, the direction of electron is due to the fundamental property, and this is due to the potential difference topic. Please do let me know, Maria, Aisha, and Abdul. Is that clear?
Yes, sir.
Any doubt so far to you, Vijay? Please do let me know. Clear? That's great. So that's why the direction of electron and the direction of conventional current are opposite to each other. Like most of the students, like this is a very simple thing to understand, but sometimes most of the students find basically get confused. And that's why it is important to clear this thing properly. Okay. So the direction of electron is from negative to positive because of the fundamental charge property. Clear? And the electron, basically the electric current flows from positive to negative due to the electricity flows from higher potential to lower potential. Am I clear to all of you? Please do let me know.
Yes.
Right? So this is called external thing. It's the external circuit thing. Because right now the wire is external property. This connection is external. That's why this is called external circuit. And this is basically internal circuit. Am I clear to all of you? Please do let me know, Mariam, Zainab, and
Yes.
sure.
Yes.
Now let me write this thing over here. The first point, the direction of electron is from negative to negative terminal to positive terminal in a metal. Is that
Did
clear,
you got
everyone?
a diagram also?
You can draw the diagram, yes, because that will help you to understand a little bit how that why there is an alignment, why there is not alignment, because of the potential difference maintained between the wire across the two points. Okay. Next point is that, so basically how to basically get a continuous flow of electric charge is basically to simply connect a battery to get a potential, basically potential difference between the 2 points. Clear everyone? So the simplest way, maintain potential difference between two ends of a conductor so as to get a continuous flow current to connect the conductor in the terminal cell or a battery. They are all, please let me know.
Yes.
Okay, that's it. Okay, so that is the electric. Okay, now simply, and I've told you that the conventional direction of current is from positive terminal to the negative terminal through the outer circuit. Okay, the conventional direction of electric current is from positive terminal to the outer circuit. Just give me a moment. So please write it down. Just give me a moment. Okay. Yeah. Is that clear to all of you? Please do let me know.
Yes.
Yes, sir.
Up so far. Are you sure? Is that clear?
Yes, sir.
Sure. That's great. Now let's do one question based on the electric current, and so that we can understand how to implement the formula of the electric current with respect with in the context of electric charge in the time. Okay. Sorry everyone, actually my voice is not that much good right now because okay, let me let me solve it for you. Question is saying that an electric bulb draws a current of 0.25 ampere. So I is basically your 0.25 ampere. Okay. And time for which it is basically drawing the current, that is 20 minutes. So 20 minutes is the SI unit of time or second is the SI unit of time?
Second.
Second. So I have to convert it into seconds. Okay. So 20 into 60 seconds, that is coming out to be 1200 seconds. Okay. Now we need to find the charge flowing through the circuit. Okay. That is simply just apply the formula, that is I is equal to Q by T. So I we have as 0.25 is equals to Q, we need to find charge. So time is basically 1200 of seconds, right? So charge would be equal to, right, charge would be equal to 0.25 into 1200. So that is coming out to be 300 coulomb. Is that clear, everyone? So this is the answer. It means that 300 coulomb of charge is going through the circuit, right? Okay. Let's do one more question. I'm sharing one more question for you. Please do this question, everyone. Any answer so far by anyone? Okay, I got the first answer by Mariam. Okay, Mariam, please to let me know the answer of my Zainab, Abdul. Any answer by Zainab? Abdul, sorry, Abdul?
Yes, I'm starting it.
Okay. Zainab, it's always capitals, okay? In the chat, it's okay, but always write it in the capital.
Okay.
Yeah. No answer by Abdul. Sure, that's it. Okay. So I is equals to 0.36 ampere of current, right? And time for which it is basically flowing through the circuit is 15 minutes, right? So simply just convert it into seconds. So that is coming out to be 900 seconds, right? Need to find the charge flowing through the circuit, okay? In that time, simply I is equals to Q by T. So Q is equals to I into. Is that clear, everyone? So I is 0.36, 0.36 into 900 coulomb. So that is coming out to be 324 coulomb of charge. Is that clear to all of you?
Yes, sir.
Any doubts so far, 21? Okay, fine. Please do this question. This one. Please do this question and let me know the answer. This would be the last question for this class. Okay. And, okay, so from this class onwards, our new topic will start, that is Ohm's law, right? So it's a request to all of you, please do the revision of the previous topics that you have done so far, charge, potential, and the current, so that we can understand the Ohm's law topic properly. Okay? Because Ohm's law basically is based on the potential difference and the electric current. Okay, everyone? And after this class, we will be having an assessment. So please check out the assessment as well. Okay?
So what are we supposed to find here?
Energy, work done.
Can you repeat?
Work done, work done.
Acha.
If the energy is saying that, it means that we have to talk about the work done. Okay?
Sir,
Yes, Maria.
sir, formula for work done is
For potential, V is equals to W by Q.
okay.
Can you repeat?
V is equals to W by Q, potential difference formula that we use.
Oh, okay.
Okay, Maria.